A small plane which is to fly from Dauphin to Brandon. This is a distance of 166 kilometers. The pilot has 45 minutes to make the trip, and the direction of Brandon is south to east. There's Dauphin right there. Brandon is way down there. The wind speed is 25 kilometers an hour, blowing towards west, 35 north. That's the wind over here. Now, is this an actual vector?
Yeah.
Did anyone measure that?
No.
I hope not, because I didn't actually ask you to do that or intend to do that. Now, oddly enough, you would think that putting a map on there would make it easier, but in my experience, when I do this with kids, the map actually confuses. What do you mean? Did it confuse you having the map there? A little bit? Yes, no? Okay, I see a few nods and I see a few shakes. Which way is, let's just stop and think about this for a second. Which way is the wind blowing? Up and to the left, right? So if I just head straight to Brandon, where am I going to end up? Exactly, over there in Rivers, exactly, somewhere like that, right? So where do I have to aim so that I end up in Brandon? Yeah. I don't know how I did that. I gotta aim over there somewhere. Right? And then the wind's gonna blow me back towards Brandon. Okay? Now, as I said, I think that the map actually confused people a bit. Okay? Part A says, Anna, calculate the resultant velocity in kilometers per hour. How do we find velocity? Velocity is distance over time. Right? You guys should know that from grade 10, I think. How far is the distance? 166 kilometers. What's the time? 45 minutes. Now, should I divide by 45? How come? Not in hours, right? So you're going to have to convert 45 minutes to hours. I'm looking to see looks on faces because I made that mistake on purpose. I looked up to see how many people just blindly wrote it down. Did anyone's little alarm go off? Hold on, that doesn't seem quite right. Kelly, it looked like you were thinking that didn't seem right, right? It's not 0.45 of an hour exactly. I mean, what is it? Well, 45 minutes is 3/4, right? 0.75. How would you do that if you didn't just know it was right on the quarter? Like, what if it was 42 minutes? Sarah, how would you convert 42 minutes to hours? Divide by 60, right? You would have to divide by 60. So 45 divided by 60 on your calculator will give you 0.75. Okay, so now I can find the result, velocity. If only hours were decimal, right? So it was 100 minutes in an hour. Oh, the day be forever, wouldn't it? Wonder why they came up with 60 minutes in an hour. 221? Is that what you got? 221.3. Whatever. I don't get too excited about rounding off and stuff. I just don't. I care about steps. So it's 200. You need to be going 221 kilometers per hour to get there in time. That is the resultant speed, resultant velocity. This is the wind speed. We're trying to find the plane speed. So you might remember from yesterday, resultant, maybe it was the other day, resultant is plane plus wind, right? And so I'm solving for plane. So plane is resultant minus wind. Right? Everybody with me? Lane, you missed this yesterday. Okay, so how do we do vector subtraction? We simply change it into a addition question, right? So plane is going to be resultant plus minus wind. Right? The resultant plus minus wind. How do I make a negative wind? What does that do? What do I have to do to make a negative? Flip it around, right? Opposite direction. So instead of west 35 north, it's actually going to be east 35 south, which is like that direction, right? You're going to take that and you're going to add it to the result. So the resultant, now if you do this, If you do this on the map, what's the problem with doing it on the map like that? What vector did I just draw? I drew the vector that shows the distance from Dauphin to Brandon. But we're not dealing with distances, we're dealing with what? I'm dealing with speed. So again, that's why the map can be a bit confusing. Okay? But I'll come back to the map in a bit, I promise. I'm going to put a blank page. You guys probably have room, right? If you have to, you can flip over. Okay? So, I'm going to take that resultant plus minus wind, and the resultant was 221.3 at south to east. And we're going to add the negative, which is, oops, the wind speed is 25 at east, 35 south. 25 at east, 35 south, right? That's the negative. So now it's just vector addition. Forget the map, forget flipping, just do vector addition. I need a scale. Now, unfortunately, when you do nice, neat questions, it would be like 175 or something, right? But here it's 221.3. So I need a scale. I need something that will go into evenly 221.3. Well, nothing's going to go nice, right? 10 would be, if I made it 1 centimeter equals 10, then I need 22 centimeters long. That seems a bit long. How about I just go 25? And then this would be 1. Do you want to do that, or do you want to do 20? Let's do 20. 20 feels good. And really, experience is going to be your best teacher there. You just got to sort of jump in and try and see what works. So 1 centimeter equals 20. So I'm going to have to actually do this because I can't actually do it in my head. 221.3 divided by 20. $11.06. You know what? Are we going to be able to go 0.0? Yeah. Let's just go 11. 11 centimeters, right? 25 divided by 20 is going to be 1.25. Let's round that up to 1.3 centimeters. Yeah? Now what are we doing? What's next? Now we have to actually draw it. Right? We have to actually draw it. Do you want me to do it with a ruler and a protractor? Because it takes me a little longer. I'm not hearing a lot of feedback. It's scaring me. Okay, so south to east. So first off, I need a reference line. That's not a very good reference line. It's got to be straight. Okay, south to east. So protractor. Right there. And I got to go basically 11 centimeters, right? Okay, that didn't work out so good. Okay, I'm off by a little bit. It's hard for me to do it here. And then I'm going to go 1.3 centimeters at east 25 south. So I got to do reference line from there. East, and I'm going to go 25 south. Anybody thinking about a pilot's license? Because you'll have to do this. Hey? Yeah? $25, east 35 south. East 35 south, and I'm only going 1.3 centimeters that way. One 1.3. I think I went too far. Yeah. Sometimes it helps to put the arrowheads on after because it kind of makes it hard to measure. Okay, and then I'm going to draw my, now this is actually the plane speed, right? This is one here is the resultant. This is minus wind, you should label it. So then this one here is going to be the plane speed from there to there. Didn't we say about 10 minutes ago, where did you have to aim to end up in Brandon? Someone said Carberry. There's Brandon. There's Carberry. Right? You can think it through after. Now, how do I find out that distance or that velocity? I'm going to have to actually measure it. It's going to be a little more than 11. Like 11, no, 12.2-ish. Takes a little while to do this. Okay, 12.2 centimeters. Now how do I convert that into kilometers per hour? Times by 20, exactly. That's going to be 24.4, right? Or 244 kilometers per hour. Do we need the angle? What was I supposed to think of, Vinny? What was I supposed to think of? Pineapples. Too late. Now we measure. Oh, now how do I measure this? Where do I measure from? I have to measure from straight south, so I should probably do it this way. Measure from straight south, it's going to be a little bit more. Yeah, I've got 10 degrees, so that's going to be south 10 east. That is your plane vector. Now, does that sort of make sense, what you would see on the map? Right? You have to fly over here so that it blows you back towards Brandon. Makes sense. Does that help when you're thinking of vector subtraction, do you think? So, no? Does it make it worse? Yes, the map can be confusing. But that's why I kind of threw that in there. So that if you do encounter something like this, maybe one of the strategies might be ignore the map. Because sometimes the map is confusing. Why is it confusing here? Because we're dealing with distances in the map, but we're really talking about speeds. Okay, that's kind of the point of my little rant today.